Hey guys, this is Patrick from STH, and today we're going to take a look at a really cool 8 or 10 GPU server from Tyan, and this one is called the Tyan FT83A-B7129. But that's actually the higher level model name because the actual model name for this, because there are a couple different variations, the one that we're going to be looking at is the B7129 F83AV8E4HR-N. And yeah, these model numbers are very hard to remember, but if you do see a 14 in the middle of a model number that kind of looks like this at Tyan, that actually is a different model that has more drive bays. We're going to talk about that when we get through this. And so in this video, we're actually going to do something that's a little bit different, and we're really going to incorporate some feedback that I got at OCP Summit this last week. And that feedback was really like, hey Patrick, you guys do so many GPU server reviews. Not only do we do GPU server reviews that you see here on YouTube, but we do even more GPU server reviews on the STH main site. And so, the feedback was really like, why some of the differences are, why a server is made in a particular way and not another way, and like, what's going on and what's the reasoning behind that? What are people thinking? What do customers want? And so like, why is a server the way it is? And so the thought was, in this video, I'm going to go through a couple of those little vignettes and just kind of talk about some of the differences in terms of how you could design a server or how servers are designed. And we're going to show, what the design decision was that Tyan made. And really the idea there is just, I want to share with everybody and just kind of explain, why GPU servers all look a little bit different, because I think a lot of people just kind of like, oh, it's an 8 GPU server, 10 GPU server, but like, what's the difference? Like, who cares? But there actually are some major differences, and I want to get into those during this video. So if you like that, well, why don't you give us some comments down below? If you don't like it, feel free to give comments too. We're just going to try it out and see how it goes, so let me know. And the basic game plan is we're going to start with the hardware, and specifically what I wanted to do was start with like the exterior of the chassis, and then I think we're going to get into the interior. Sometimes we do like front to back, but I think we're going to just kind of focus on the exterior first and then get inside. Hey, just real quick, I do want to note that Tyan did send us this. For full disclosure, they did send us the system. It is going to go back after we do this. And we also, they did ask us to do this before Supercomputing 21, because I think they're actually going to use this server as kind of like one of their big, I guess, centerpieces for that show. And they have a virtual booth that, you can see. We'll link that in the description. But if you want to go learn more, you can totally go do that. But they wanted us to have the review done before that. And I said, yeah, I think we can go do it. So just so you guys know, this system is going to go back, but just want to make sure that everybody's aware of what's going on here. Okay, so looking at the front of the chassis, what you're basically going to see is that there's a ton of space that's dedicated just for airflow of this 4U front panel. And really the reason for that is that you have to remember that there could be, say, 3 kilowatts worth of GPUs in the back plus the CPUs. I mean, this is definitely a system that can go, 3.5, 4 kilowatts, no problem. Our configuration was a little bit below that, but just kind of keeping in mind that this is a system that can absolutely use a ton of power. And because of that, you actually need a lot of airflow to be able to cool that. But at the same time, people also generally want to have a lot of storage, or a decent amount of storage at least. Think about things like if you had like video coming in from security cameras and you needed to do analytics on that, which is kind of actually a pretty common thing for a GPU server. And so if you have that, you kind of want to have your storage locally, so that way, you can avoid going over the network to go and pull all the video files and images. You then process things on the local CPUs and then feed the information to GPUs to go do inferencing or training or whatever you need to go do. So that's why on the front of the system, there are a total of 12 3.5-inch bays. Now, a total of 8 of those are just purely SAS or SATA, but then there are 4 other drives. Now, of course, you can get SAS only if you have a SAS controller. It's SATA native, but then the other 4, you can actually get NVMe on those. And that's a big deal because sometimes you might want to go and put a little bit of fast storage, whether that's cache storage or whatever, into a server. And so that gives you kind of a mix where you could have like hard drives and you can have NVMe storage, and then, you can just have that all locally. Now, something cool that Tyan has done in this generation is that they have moved to a toolless 3.5-inch drive tray. So you basically just swing the little arm out, you plop a drive in, and then all of a sudden you're ready to go. Now you can go put a 2.5-inch drive in this, but you basically probably then would just need to kind of screw that thing down so it's not toolless. But if you do a 3.5-inch drive, super easy. Now, just above that, what you're actually going to see is in our system, you're going to see this big blank, but you might see little tiny slats, and hopefully it's going to come out in a photo or B-roll or something. You may see just kind of this like middle section or upper middle section. And what that actually is that there is another version of this chassis that does take that section and allows you to put 10 2.5-inch drive bays there. Now, our version, we don't have that, and this is actually kind of a kind of early version. I don't think this is actually, this is listed on the Tyan website as we're doing this video as still coming soon. We're gonna talk a little bit more about that in kind of later in this video, but that is an option that if you do want more storage, you can get extra 2.5-inch bays. Now, there always is a drawback to actually putting more storage into a GPU compute server. And that drawback is usually just the fact that you start restricting airflows pretty significantly if you go and fill up the entire front of a chassis with 3.5-inch or 2.5-inch or a mix of drives. It just restricts too much airflow to get enough airflow to the GPUs. And so that's why you typically always see at least like 1 or 2 U that are open. And in our system, we have 2 U that are open. But it is important to also just note which 2 U those are. Those are kind of up at the top of the chassis. And in most GPU servers, you'll see that if they're a 4U GPU server, you're going to see that the top 3 U is usually accelerators. So usually you'll see storage towards the bottom part of the chassis because that would be the portion that either goes to power supplies, adding cards, or whatever. And you don't just need as much airflow for that than as you do for all the PCIe GPUs or accelerators. So that's just a little bit about why these systems are designed like that. And something else that Tyan did that I actually really like on this system is that they do have kind of the front IO. So if you need, a serial port, or you need a VGA port, you need USB or any of that kind of stuff, all that's actually on the front of the system. If you've ever been behind a GPU cluster where you have just racks and racks of these systems with all these GPUs in them, you'll know that the hot aisle is actually really hot. And so being able to service with a KVM cart if you need to on a cold aisle is actually a huge benefit because, well, it's kind of easier to deal with a little bit of cold than it is to just get blasted by hot air. I mean, I get like so dehydrated when I'm behind GPU clusters, it's insane. So it's really great that they thought of that and they had the part that you would service in person on the cold aisle, and I just really like that design. The other thing that you don't see though is that you don't see the management port on that front aisle. Instead, you see it on the rear of the system. We're gonna get to that in a second, but it's really nice that it's not up there because otherwise you get these systems where like you have a front management cable and then everything else is cabled off the rear of the thing and it just kind of looks weird. And so it is just kind of nice that Tyan made that design decision. But speaking of that management port, let's get to the rear of the chassis so we can see what's going on there. Okay, on the rear of the chassis, you're basically gonna see, I don't know, maybe like 3 or 4 big features, right? There's gonna be a massive area on the rear of the chassis that's really designed to go and be the IO, expansion slots and stuff that you would use for GPUs. Now, one of the challenges is that we're doing so many of the GPU reviews, GPU server reviews, that we had to go pull the GPUs out of these so that they're in the data center right now. We don't have a ton of them extra, and so we had only 8 A40s, and that's just what we had. So, but at least with this, you can actually see now the PCB that's below them, so that's also kind of cool. And then at the bottom of the system, you're going to basically see 2 features. You're going to see an array of 4 1.6 kilowatt power supplies, and then in the middle, you're actually going to see this kind of like little I/O module. Now, this I/O module you can actually go pull out, and it has basically 2 major features. First, you get like the dedicated management port and USB ports, and those are really on one side of the chassis. And then the other thing that you get is an OCP NIC 3.0 slot. So if you need high-speed networking and you don't want to take one of your valuable PCIe slots, you can actually go and just kind of use that OCP NIC 3.0 slot and then get high-speed networking there. Now, of course, the challenge is if you have like a 10 GPU system and you have a single NIC, well, that single NIC only goes to a single CPU. And so that is just kind of a kind of known thing with these servers. And so just want to go point that out real quick, but we're going to get, I think, to the bigger item, which is like how this whole thing is designed. So one of the key things that you'll notice with these PCIe GPU servers, especially the 4U servers, is that there's like kind of 2 major ways that you do this. One way that people tend to design these servers is that they'll put the power supplies all to one side. And then often, because you only really need 3U of space for normal GPUs, what you actually see is that the bottom tends to get used for things like accelerators. And then the other way that you sometimes see these things is that you actually see a configuration like this Tyan, where there'll be a board that goes across the entire chassis, and then the entire top three of the chassis is all just expansion slots and PCIe slots. And then at the bottom, you're gonna see power supplies and usually a little bit less IO, which is kind of the configuration that Tyan has here. But make no mistake, this is not an accident. This is definitely a design choice, because what this allows you to do by putting the power supplies at the bottom and kind of limiting your IO because of that, it allows you to have a maximum. You get the entire width of the rack mount server to go and put PCIe expansion cards. And that means that you can put more than 8 cards in a system like this. That is exactly what Tyan is trying to do here. And so let's get inside the system and actually look at that PCB and talk about what the heck is going on this thing. It's actually pretty easy. If you've seen these things before, this is actually a pretty common design, but let's just kind of talk through it and work kind of through what's going on with Tyan here. So what you're going to see is a total of 11 PCIe Gen 4 by 16 slots. And well, that allows you to do something, and you might say like, well, why do you have 11 and what's this whole funky spacing in the middle here? And the real idea is that a lot of people will actually only run 8 GPUs in a server like this. It's a whole balance in terms of, you know, performance for the CPUs and memory and also power consumption, all that kind of stuff. So sometimes you'll only see 4 GPUs per CPU. But the other way that you sometimes see it is that people will say, hey, heck with that. I want to go maximize my investment in my CPUs, memory, drive, system, all that kind of stuff. And instead of having just 8 GPUs, I want to have 25% more and have a total of 10 GPUs in the system. And so what you'll notice in the system is that there are actually 10 GPU slots that you could use. And with those 10 GPU slots that you would use, you actually have double width spacing. So you can go and put full GPUs and full double width GPUs and put a total of 10 of them across in this chassis. Now, the double PCIe slot that you kind of see in the middle, that's actually really interesting as well, because what that specifically is that's really usually designed for like a network card. So you could put something like, I don't know, 100 gig Ethernet adapter or something like that in the system between these GPUs and still have space. And so if you kind of look at the board from that lens and you kind of say like, okay, well, what is this for? It's really to go and be able to put those 10 GPUs plus the high-speed network card. I will just note real quick that we did have to do a little bit of blocking of airflow here just because, well, we kind of had a really early unit and we didn't have the block for 8 GPUs. Usually what you'll see is that in the middle of these systems, you'll have a kind of little airflow guide that if you only have 8 GPUs, there'll be an airflow guide to kind of block off some of this middle section. So that way you can divert airflow where it needs to go. Some companies will actually do it on the side, but there's just kind of something that you have to basically do to make sure any GPU system functions properly. You have to make sure that you have the right blocking versus GPUs and accelerators that are open slots for airflow to go through. So just kind of mention that real quick, but let's kind of keep going. Now you're going to see 2 heat sinks that are on that PCB, and you might be wondering what those are. What those are actually are PCIe switches, and specifically they're PLX or PEX 88096 PCIe switches, which means that they have 96 PCIe lanes for devices, and that they're also PCIe Gen 4. Now, there were previous generations of these systems that use PCIe Gen 3 switches. This is, of course, PCIe Gen 4 because this is an Intel Xeon Ice Lake system. And so because of that, we actually have, the newer, faster, higher speed PCIe switches from Broadcom. And the reason that you typically see things like these PCIe switches on here is actually that when you have GPUs and you want to do peer-to-peer traffic, the GPUs these days can actually talk over a PCIe switch and avoid having to go all the way back to the CPU. And so you can do things like sync across a bank of GPUs that's on a PCIe switch without having to go and kind of saturate that backlink to the CPU. And so that's actually a pretty big feature. It used to actually be a bigger feature, and something that we used to see was that people will go and build these like kind of just giant PCIe switch architectures to be able to do a single route that can handle, 8 GPUs or something like that. And that used to be a lot more common back in the day, but kind of software has picked up. And so it is still kind of common that you would see these PCIe switches, but there used to be this whole single root thing that we actually did reviews on STH. And you might be wondering, well, why do you not have direct, PCIe to GPU connectivity? Why do you have to have these switches? And the reason is that if you have 10 GPUs, all of them are by 16, that's 160 PCIe lanes. And then usually you want other PCIe lanes for things like your network controllers. And usually you want at least 2 network controllers in a system like this. And then also, you may have NVMe SSDs, you could have a SAS controller. There are all kinds of RAID controller. You could have all these kind of devices that also eat up PCIe lanes. And dual Intel Xeon or third generation Intel Xeon Scalable Ice Lake Edition, CPUs only have a total of 128 PCIe lanes between them, plus a little bit of extra from PCH that we're just gonna pretend that don't exist. Now, I have mentioned that this system is listed as coming soon. So you kind of expect that they're gonna be really rough systems when you kind of get early systems like that. But we actually had a feature that is really important for the GPUs that a lot of people kind of overlook that we actually got with this system, which was super exciting. And that's just the fact that we got power cables. And these power cables, you'll see that there are two different kinds of power cables that I'm holding right now. The power cables on my left are the ones that you use for things like data center GPUs because they're able to go deliver 300 watts of power on a single cable and a single connector. Very easy. This is definitely what you would want for if you're using like an NVIDIA A100 or something like that. You would definitely use this kind of cable. Now, on the other hand, there are people that will use like consumer GPUs. And if you do that, you basically, usually have maybe say two connectors, whether there's like, two 6-pin or 8-pin and 6-pin, an 8-pin, maybe there's two 8-pin connectors. I don't know. There's all kinds of different connectors. And so that's actually what these cables over here are for, where you have the single connector from the motherboard, and then you have two connectors per cable to go to each GPU. I can't stress this enough, but if you do purchase a system kind of like this, where you're going to have PCIe accelerators, and you're thinking like, hey, I can go use a consumer GPU, make sure that the vendor has the appropriate power supply cables, because otherwise that can be a total headache to go and find like, oh, hey, the power cables that I have, they don't work with my GPUs. And it's just, there are adapters out there, but it's just a total pain in the butt. And you don't really want to go and have extra cables in these things, blocking airflow. And so just make sure that your vendor has these cables. And that's a very big thing, actually. Now, the whole GPU PCB and stuff, that's all sitting over the power supplies, if you remember. So you have the power supplies below, you have the GPU PCB, and then you have all the GPUs on top of that. And then, what you really have is you have a series of cables and connectors that basically connect the main motherboard of the system to that big PCIe thing. Now, on the motherboard, what you have is you have two Intel Xeon Scalable and third generation Intel Xeon Scalable Ice Lake Edition processors. Now, with these Ice Lake Edition processors, you get a whole bunch of new features, and just kind of some of them that are important for a system like this. You do get PCIe Gen 4, you get 128 lanes, which is a big upgrade from the 96 PCIe Gen 3 lanes that you would get on a dual socket Cascade Lake system. So certainly this is a big upgrade in this generation for Intel. Now, let's just call it what it is. A lot of the vendors out there actually do have AMD EPYC systems or alternatives, but there are people that actually very much prefer the Intel systems, especially if you have something where you have like pre-processing or something like that, where you might need something like AVX 512, maybe you need VNNI or something like that. That's actually pretty common. And so there are people that just, have a preference for one over the other. And so it is important to have both the option to have, AMD, but also Intel Xeon scalable processors, because just, it allows you to go and say, here's my workload, what is the best fit for me? And there are some other technologies that you get as well with third generation Xeon Scalable that you don't necessarily get with AMD. And a really good example of that is that in a system like this, you may want to go use something like Intel Optane Persistent Memory or PMEM 200, and that gives you up to 512 gigs per DIMM, but that could also be very persistent, very, very fast persistent storage. You can also have additional memory. So if you wanted to go like to a very high memory count, you can totally go do that. This does have a full set of 8-channel memory per CPU, so 16 channels per CPU, and also 2 DIMMs per channel, which means that we get a total of 32 DIMMs in the system, along with the 2 sockets. Okay, now here's a little tiny feature, or maybe it's actually kind of a bigger feature in the system, but I just kind of think it's totally cool, so I want to go over it. And that's the fact that one thing that I think a lot of people that read STH or have read STH over the years know is that I do not like the little flimsy plastic airflow guides. I just dislike them with a passion. And they have been used by many vendors in systems like this. And they're just a total pain to go, once these things are all configured, to like kind of go get in place, get seated right. These are 4U systems. You got to kind of like move those things around. And those flimsy ones, I absolutely hate it. I mean, we've been using them since like the Xeon E5, V1, V2 era in this type of system. And I just dislike them with a passion. But Tyan has kind of gone the absolute other way. Not only are they doing like, say, something like a hard plastic airflow guide, but they actually have a metal airflow guide that directs air both over the CPUs along with some of the memory slots as well. And that is just, to me, totally crazy, because it is pretty common that you see the flimsy one. It's also kind of common that you see kind of the hard plastic ones, but you almost never see full metal airflow guides. And so just as a nerd that looks at these things and does, I guess we're doing 5 GPU servers just this month, and we do a ton of these systems, and that is definitely a differentiated feature, which I think is just super cool. And so just talking about this, I was like, wait, the server is sitting right behind me. Why don't I just go pull this thing out? And so what I want to talk about next is actually the fan module. So these fan modules are actually kind of cool because you can kind of see they're actually hot swap and they're really easy to go service. But at the same time, you can actually see that there are 2 fans in the carrier that are oriented vertically. Now these are 80 millimeter fans. And what this basically allows you to do is get a ton of airflow through the entire chassis, right? Because you have these 2 fans that are stacked on top of each other. It just means that the entire 4U chassis is just blowing air like crazy. And then also just kind of how Tyan has this set up internally, you actually do get, if one failed, you'd actually still be able to run your workloads. So that's actually kind of nice. There are some systems that only have like 1 set of fans that, service different GPUs. So if you get one of those systems and you don't have these two fans that can actually cool something, you only have 1 fan per 2 GPUs. Sometimes what can happen is if that fan fails, then all the rest of your GPUs are going to be fine, but you're going to have 2 GPUs that will overheat. And so having a design like this is actually kind of cool. I guess that was kind of a pun too. Also, just to note, these are counter-rotating fan modules. So it is kind of like that there are, I guess, 4 sets of fans in this kind of stack configuration. So just want to kind of point that out as well. And there was one tiny little feature that I did want to talk about because it is something that's not overly common, and it is a nice feature that Tyan has that I think a lot of people would overlook. And if you look at how the fan wall is actually mounted, there are actually little rubber grommets that sit on the screws that hold in the fan wall. And while that may seem like a very small detail to folks, just know that when these things are actually running kind of at full bore and the accelerators are going, these fans actually vibrate quite a bit. And when they create that vibration, it actually does shake the chassis quite a bit. And so having these little rubber grommets is really there to go and isolate the fans from vibrating the rest of the chassis. It's like a tiny little thing, but a lot of people don't do that, or a lot of companies don't do that. And it does show that, Tyan has been making these systems for years, and just kind of that they would think of something like this. It's definitely something that's come from customer feedback and made its way into this product. All right, home stretch of the hardware overview. Let's get to the front of the system, and just above all that drive bay and all that kind of stuff, at the very top of the chassis, you're going to see these kind of 2 kind of strangely mounted PCIe by 16 slots. Now in our system, only one of the 2 of these is actually hooked up to data. There is the other one that is actually hooked up to power, but not data. Of course, you can change the way that your cables go in the system and actually hook this thing up if you wanted to. But the idea, I think, with these are really that these are there for things like, if you wanted to have a RAID controller or something like that, you would then go and put them into this kind of, I guess, slot. And then you have a second one. So if you want to have 2, you could go do that. Okay, so let's kind of move on and let's get to management. This uses Tyan's Megrac SPX, so you do get things like IKVM and all that kind of stuff. We actually have stuff that we'll link on down below if you want to kind of just go check it out and kind of, I guess, get a better view than what we're going to go over here. I just don't want to go through the management interface that we've done a gajillion times again, because we've done it a gajillion times at this point. But if you want to go check that out, you can. Now, in terms of performance, we kind of wanted to look at 2 main things. Now, in these systems, just being frank here, if you have a PCIe solution where you have PCIe switches and you have the same GPU, same PCIe switches, by far the biggest difference that you get in terms of performance is just based on cooling. And really the question is can the system cool the GPUs that are in there, or can they not? So when you're thinking about a system like this, the way at least I would go and kind of stratify the different solutions, or as I would figure out kind of what kind of accelerators do I want to put in there. I'd figure out what kind of topology do I want. I mean, do I want an NVIDIA NVLink topology? Do I want PCIe? Do I want direct to CPU PCIe? Do I want the PCIe switch PCIe? Do I want single root or dual root? I mean, what are the different kind of topologies that I might want? And then, I think that's kind of like the first filter in terms of when you're looking at these systems. But then the next big one should definitely be, can the system cool the GPUs, Or is it going to be the case where, the GPUs are going to overheat? And if they overheat, that means really that they throttle down. And if they throttle down, you lose performance. And these are generally really expensive systems, right? Once you have these accelerators in there, these are not cheap systems. And so you don't really want them not performing well. And so you do need good cooling. And there are actually two aspects, because there used to be, especially in the old days, quite a few systems that couldn't handle like the top bin CPUs along with the accelerators. And so this is just something that, we wanted to test both the CPUs and the GPUs. Now, this system claims that it can take up to 270 watt processors. So we took the Platinum 8380s and we put them in there and we said, well, this is the 40 core high-end CPUs that Intel has. Like, can this cool, and how does it compare to just kind of our standard 2U server in terms of performance? And what we generally saw was it was pretty close. This was actually a little bit slower, but it was like 0.5%, which is pretty much what we consider test variation. So I would say that, for me, I would say that this is close enough to our baseline that this is just kind of normal variation. And I would say that this can actually cool 270 watt TDP CPUs. Now on the GPU side, we did the same thing, but one thing that we did do is we did block off, because we only had 8 NVIDIA A40s, we had to actually block off the slots that were empty and not occupied. That's kind of normally what you would do, and we would totally have put 10 GPUs in there. But frankly, GPUs are very hard to get these days, especially GPUs that are like $5,000-6,000 a pop or more. So we had 8. That's what we had. Sorry, guys. So what we want to do is just compare this to a baseline and just make sure that the GPUs, even if they're all the way at 300 watts TDP, like the NVIDIA A40s are. Wish we had A180 gigs, but no way we have enough of those for this, right? We just want to make sure that it could cool a 300 watt GPU because, frankly, if you have a 300 watt GPU in a PCIe slot, then frankly, if it's a lower wattage GPU, you should be able to cool that no problem. So that was kind of the thought process there. And when we kind of looked at it again, it actually was pretty good. We're about 1.2% just kind of on average lower than we would have expected, which is actually a little bit more than I would probably say is just a normal. Usually we use like 1%-ish or 1.5% for our test variation. So this would probably be kind of at the higher end of what we would consider a test variation. But then again, just remember that we did have to do a little blocking off of the airflow because we didn't have a full 10 GPUs. So there was a little bit of funkiness going on because of that. And frankly, it was pretty close. So I think overall we're okay. And, frankly, if it was 1.5%, that seems to me to be pretty reasonable. If we see something that's more like a 5 to 10% delta, that usually is a big warning sign. So 1.2% to me just kind of feels okay. But yeah, let's get to that next thing that you're definitely wondering, like, okay, so how much power does this thing use? Now remember that we have a total of 4 1.6 kilowatt 80 plus platinum power supplies. And just to be really clear real quick, these things are 1.6 kilowatt power supplies each if you're at over 200 volts. If you're kind of down in the kind of 100 to 120 something volt range, this is only like a 1 kilowatt power supply. And so it can accept both voltages, which is actually kind of cool for, a GPU server. A lot of them nowadays are only 200 plus volts, but at the same time, you lose a lot of efficiency. So that will impact the configurations that you can have in a system like this. Now, we got our configuration up to about 3.5 kilowatts, maybe just a little bit south of 3.5 kilowatts, which is pretty good. Now, that being said, there's definitely room to go up from there. I mean, you could put 2 more 300 watt GPUs, which would be 600 watts plus, call it 10% or so for cooling, so it's about 660 watts. And then, you could put more drives in there and you could put, I guess, a DPU or something like that in there, and that could be, 50, 60 watts itself. And so overall, I mean, you could definitely put a lot more into the system. And so if you are at over 200 volts, this system is designed to be a 3+1 redundant system, which means that you could lose 1 power supply and still run the system and get up to 4.8 kilowatts of power budget total for your system. And so overall, I think the system performed decently well. We were definitely not at the top end of a configuration for this, but it was like the biggest one that we could basically get for the server in the time that we had. So that's kind of what that is. So overall, I hope you like this look at a 8 or 10 GPU server. I mean, this is actually something that is really cool. There are a lot of people that prefer the PCIe just because of the, flexibility of the PCIe solution. And so they really like these kind of servers. And so I just kind of thought it'd be cool to show you another one of these. And then the other just kind of bit is I just really wanted to explain some of the design decisions that Tyan made and why they made those decisions. Hopefully you found that helpful. And if you did, feel free to leave comments. If you didn't, leave a comment as well. Now, if you do want to find out more about this, again, you can go to the Supercomputing 21 virtual booth from Tyan because they definitely have more on the system there. This is going to be one of their flagship systems for that show. So definitely go, check that out. There's probably more information than we had, although I try being pretty thorough on these, but they may have some more stuff there if you'd like to see that. And hey, if you did like this video, well, why don't you give us a like, click subscribe, turn on notifications so you can see whenever we come out with great new videos. As always, thanks for watching and have an awesome day.